So let's start with our hardware component, and let's say we want to add a new desktop class, and we'll also have a new class of kind, let's say game console. Game console. There we go. And let's make public also this guy. And anyway, if you go and look at the GameConfig description of the builder pattern, you will find out that they say that there's actually no reason for having a common ancestor to these to the various product types that the builder can build. And they say it's because, yes, after all, the algorithm is going to be the same, the steps in the builder are going to be the same, but that doesn't mean that the final products will expose a common interface. They say it's unlikely that this will be the case, and so there's no need to consider a common base class or a common interface for the various products. I think that actually this is bullshit, because if the steps for the creation of the product are the same, then the components of the various products are not going to be that much different, and so probably the behavior of these products is going to be similar, at least in some respect. I would say that probably this pattern could benefit from a common product base class, but I believe they didn't mention this, because if you also incorporate a common base class, then this pattern becomes a little bit too complicated, and even more important, it becomes suspiciously similar to other design patterns like factory method or abstract factory. And so just for the sake of keeping its identity separate, I think they made the choice of not considering a common family of products. But anyways, we'll follow in their step here and say, okay, desktop and game console, yes, they're both hardware, but let's say they don't belong to the same family of objects. But for my simple toy example, they will need to have some common properties. So let's create another class just to avoid code duplication. Let's create another class. There will be something like, hardware resources. Say, hardware components, and this class will have some basic hardware components that will be common to both the desktop and the game console. Let's say RAM, an SSD, or an old-fashioned drive, not solid state. And another way, when we want to reuse code, the most straightforward way is actually to inherit. But so we could make a common class that has its properties, and then have game console and desktop inherit from it. But composition will work as well, and we heard many times that when in doubt, prefer composition over inheritance. And so let's actually do this and say that the desktop, instead of having all this as a property of type hardware components, and the games console as well, and we're still duplicating the fact that they have this property in common, but at least the code is just a little bit cleaner. This is just code for example purposes, so it's going to be as simple as possible. It's not going to win any award, just to pass the idea through to you. Now we have our desktop and game console, so I think it's time to think about the it's actually time to think about the various builder. So let's try with a new class. Actually, this is going to be an interface. And we call it hardware builder. And you'll notice that And you notice that I'm not adopting the convention of using an I for interface in front of the name. I think the times for this convention are long gone. It's actually better to avoid this kind of prefix. And here my interface, and this is gonna be this piece of the pattern, the common ancestor of all builders. So let's go back here, and we want to insert our methods, and our methods will be, for example, one method that makes sense is probably 8 RAM, and we take an int giga. And let's stop for a moment and think, what do we want this method to return? Sure, we can make it void, but actually when we implement a builder, since we have to call quite a lot of methods on this builder, we prefer to use method chaining so as to have a more fluent interface and not to have to repeat all the time builder at this, builder at that, and then we can just say builder dot this dot that dot. So to do method chaining, we want this method to return a reference to the object on which they are called. So this is to return an object of type hardware builder. If you're confused about this, don't worry. When we go to implement this and to show it in action, see it's very simple. And then we probably, for our toy example, want to have a few more methods. I guess one for the SSD. And one for the HD, I guess, for the hard disk, which is not SSD. There we go. So this is our interface, and you might be tempted also to put a method that actually returns the object, but that's not what we're going to do, because actually, since the object doesn't have a common interface, the various products do not have a common interface, the method that actually returns the final product must be in the classes that implement this interface, and not in the mother interface. And now we want to go and think about also our concrete expression of these builders. So let's go to another file, like a good clean programmer would do, and create, for example, a desktop hardware builder. Let's call it desktop builder. And oops, this is not an interface, of course, but it's going to be a public class, desktop builder, which will implement our interface hardware builder. And so now we want to implement the interface, and what will happen here? Well, I guess the desktop builder will, there's many variations that we could implement here, but let's say that we have private desktop, and of course we don't see it because it's in the hardware namespace, but now we have corrected this problem thanks to Visual Studio. You see, using design pattern.hardware private desktop, and we call it desktop. Why not? And for now, I guess we can just initialize it right away. Oops, pardon. New desktop, and then these methods are going to be all very trivial and simple, because they're all going to work on the desktop. Of course, we have to go on the components of the desktop and then do the action that's required. For example, we were talking about HD, so HD equals giga. Just bear with me for the simplicity of this example. And there we go. These methods are not going to be void. We want to do method chaining, so these are going to return this. So these methods are going to return the same object on which they are invoked, and it's going to be the same here. So desktop components dot RAM equals giga. And I know some of you are cringing because they're saying that all these methods are doing basically the same thing, but we're going to correct this later on to make it a little bit more elegant. Return this, whoops, and before, of course, desktop and its components are going to have an SSD of .gigas. There we go. So here's our desktop builder, and I guess we can give it the method that we need. That is public, we could call it build, I guess. It's going to return a desktop and call it build. And this method is just going to return the final product. So it's going to be return desktop. So this is going to return the assembled desktop. There we go. So here's our desktop builder, and guess what? In our simple example, the other builder is going to be pretty much the same. So I'm going to cheat a little bit and basically just do a copy and paste for another class. And this is going to be game console builder. There we go. So game console builder, and of course this is not going to be a desktop, but it's going to be a game console. There we go. And we have to import the namespace even here. Oops, and of course this is going to be changed as well. Game console. And actually these methods are going to be the same, but for the sake of the argument, just pretend that these methods are just doing something a little bit different, or even quite a bit different in a game console rather than in a simple desktop. I guess we want to refactor this. So let's call it console. And of course this has to be changed to game console, of course. There we go. So now we have our two builders, and if you go and check the diagram again, now we are builders, we have our products, we have our interface. What we miss is the director. So let's go here and add another class, I guess, and we call it hardware director. If I can spell it, and let's call it hardware director. There we go. And it's gonna be our director. Let's give it a method. First let's give it a constructor, and let's also give it a private hardware builder. Call it builder. You know, this is representing the fact that the director is composed with a reference to a generic builder. So private hardware builder, and of course we want to give it a constructor that's going to initialize the builder that we desired. So builder. So you're not a big fantasy for names, so I can say just this.builder equal builder, and that's it. And now here's the one or more method that the director might want to use to create our product, and we'll call it, for example, assemble. And this is the method the director will execute to assemble the virus project, and this, as I said, will just lean on the builder to do whatever it thinks it's appropriate for this for building the object. So says builder 8HD, builder 8 RAM. I guess we can leave it at that for now. It doesn't matter how many calls we're doing here. So once we have all these, and actually we might want also to give it the possibility of changing the builder after I've used this hardware director. Once I've initialized it with some kind of hardware builder, we can give it another one. Like for example, I could say change builder, and same as before, hardware builder, and here we'll just say again this dot builder equals builder. You know, this way we can use the same director to interact with different kind of builder, and so to assemble these different kind of projects. So I think we have all we need now, and if we go to our little main just to make things happen. So let's start by creating the builder. So desktop builder, and of course even here we have to bring in namespace. There we go. So let's start by creating a desktop builder and call it as we want. Like builder is a great name, I guess. And let's initialize it. New desktop builder. And I know what after we do this, we need the director. So we're gonna need the hardware director. Oops, sorry. Director, and we call it director equals new hardware director. Okay, and as scroll, when we create another director, we have to specify which builder it's gonna use. So let's pass in this nice desktop builder we just created before, and now we are free to call the algorithm that will assemble our product. Go director assemble. And now, after the assembly phase, we can go and get our shiny new desktop. So desktop desk equals, and we say builder dot build. Though maybe I should call it get resource because it's actually being built already. But let's leave it at that for now. So that's equal builder.build, and then we should have a nice little desktop for us. And just to make sure, let's give it a run of debug and see what we got here. Okay, oops, there's one thing that we forgot to do, and that is we didn't initialize the components. So even without looking at exception, just looking at this, I know what the error is, and you know, of course, it's a new reference exception here. So oops. What we need to do is just to go back into the desktop and initialize this guy. Because of course, otherwise it will be just null, and we know this. And of course, we need to do the same in our game console. There we go. And now I guess we can run it again, and hopefully we don't have any other stupid mistakes. And if you go and look at this guy here at my desktop, see that the components have been initialized just as I was expecting. So now, if I want, I guess I can just switch to another builder. Let's create also a new game console builder. Let's call it gbuild. That's new game console builder. Whoops, perfect. And now, let's say, dear director, I want to change your builder and pass gbuild. There we go. And now, well, again, director.assemble. Let's have the assembly phase, and then finally we can say game console console equals, let's just say gbuild dot build. There we go. And if we give a final run again, we should see that the console has been initialized as well as we expect. There we go.